solving systems of equations by Cramer's rule. And Cramer's rule is a way that we use determinants to solve. And a system, remember, is where you're going to have an answer of x comma y, or if you have a 3 variable, it would be x comma y comma z, and so on. But you start with first, and I give it a name, the denominator for both x and y. And the denominator for x and y are the coefficients of the x and y. So I'll explain what that is as we do it. So the coefficient of my x is 4, y is 5, x is 1, and y is a negative 3.
Do you have x plus y, the coefficient of x plus y, or what? I think you read it.
Coefficients of x and y. I use the ampersand. Now you evaluate that 2 by 2. So diagonal down, what's that going to be?
Negative 12.
Diagonal up,
5.
and we always subtract. So negative 17. Numerator of x is where you replace the, and I'll go ahead and label these, the x column
What are you talking about?
with what equates the constants. So we're finding the numerator of x, that's what I use to stand for numerator of x, and you find it by replacing the x column with what the constants
I
are.
don't really know what you're talking
We're solving systems.
about. What do you mean numerator of x?
That's what it's going to end up being. You're going to come up with 2 parts of the equation.
I don't even understand what
You will when you get it all together. So this, we're trying to find the numerator of x. You find it by replacing the x column, which my x column is 4, 1 right now, but it's going to become 13, negative 1. And then you evaluate that 2 by 2.
How are we going to do that?
Now, what's the diagonal down going to be?
Diagonal negative 39.
The diagonal up,
Minus 75.
and we end up with
How do you get
how we get what?
the 13 and negative 1?
That's the constants. The constant, whatever the equation is equal to is constants. It's going to go into the x column when you want the numerator for x. If I want the numerator for y, you replace the y column with the constants. So that means here's my x column, it stays 4, 1, but my y column now becomes what's the equation is equal to, the constants.
Negative
And then we evaluate, we're going to end up with
1. Negative 4. Negative 6 equals the negative 6.
now, you have the answers right now, we're just going to write them now in fractional form. Which Cramer's rule is a great way to solve system of equations if you have nasty answers, which we're going to do some that aren't so nice here in just a minute. D, what did I say D stood for?
Denominator.
Denominator. So the denominator for both x and y is going to be a negative 17.
Probably do
Because that's what I said it is. It's the denominator.
that.
The numerator for x is going to be what?
Negative 34.
Negative 34. And then the numerator for y,
Negative 17.
and that reduces to 2 and 1. So you found the solution for x and y by a process called Cramer's rule. And Cramer's rule essentially finds the denominator first, the numerator for x, the numerator for y, and then you just put them in fraction form. And again, there's no reason to miss any of these because you don't even need b. You can sub them in yourself, right? 4 times 2 plus 5 times 1 does equal 13. 2 minus 3 times 1 equals a negative 1. Is everybody agreeable to that? Okay, now, I'm going to do one that doesn't come out so nice. Now, in using Cramer's rule, one thing you want to make sure that you always have done to begin with is you always have your variables on one side and the constant on the other. Okay? Variables on one side, constant on the other. If I have fractions in here, I'd probably get rid of them, but you can work with them. We'll do it both ways so you can see it. But first we're going to do one that doesn't come out nice. illustrate it using addition, elimination, or substitution methods so you can see what you would have had to gone through to use it if you hadn't had Kramer's rule. Now my D stands for the
Denominator.
denominator, so just remember denominator. So the denominator for both x and y are found by writing the coefficients of the x's and y's. So the coefficients of x's are what?
6 and 2.
Coefficient of y?
8 and 4.
Then we evaluate the 2 by 2. So Robert, what would you have for that evaluation?
Negative 24 minus 16 equals negative 40.
Okay. The numerator for x, and I have capital N stands for the numerator. How do we find the numerator for x?
Replace X column with the constants.
X column with the constant. So I put 15, 13 in the x column. So if I want the numerator for x, you replace the x column. If you want the numerator for y, you replace the y column. Okay, so Nathan, what will you get when you evaluate this 2 by 2?
We'll have negative 60 minus negative 4.
So what is that, negative 164?
164. One question.
Yes, sir.
If we change the order of the constants, wouldn't it change the whole problem though?
Uh-huh, but you want to keep them in the way the order is written.
Like, wouldn't that, I mean, we can, like in the normal problems, we can change the order, so how does
You
this
could, I could switch the order, but you gotta be consistent about it. I could put the 2x minus 4y equals 13 on top, and that one on bottom, but then I'd still do the same setup.
Okay.
Okay, numerator for y. What do we do to find the numerator for y?
There's the y column with constant.
Y column, so that means the x goes back to the way it was, and the y column now is 15 and 13. Okay, so we're to Aaron. You get to do evaluation there.
So it would be 78 minus 30.
So that ends up being what, 48? Agreeable there? Now, to write our answer, what's the denominator for both of them?
Negative 40.
And the numerator?
Negative 664 and then 48.
Now, what can you do to reduce those so that you have it in best form?
5, 5, 4.
4 goes into both, that would be what, 41
Yeah.
and 10?
Yeah.
And what's 8?
Yeah. So it'd be 6 and 5.
Maybe 6/5?
Yeah.
Okay, now if we wanted to check it, somebody have their calculator handy? These are easily checked on the calculator, especially if you got fractions, and you guys know how to use your fraction key. You go 6 times 41/10, or 4.1, plus 8 times a negative 6 fraction key 5, hit equal, it should come up 15.
Do you have to put parentheses?
No, not if you're using your fraction key, you wouldn't. You can do it in your head too.
Hurts.
Then if we try the second one, what's 2 times, and again you can use 41 fraction key 10, or you can go 4.1 because it's to a decimal, minus 4 times a negative 6 fraction key 5, and hit equal. Everybody come up with 13? So it doesn't take long to check them on your calculator. You just have to use your fraction key on the ones that end up not so nice. Now, let's go back just a little bit. What would I have done if I used addition elimination to solve this problem?
Divide by negative 3.
Okay, I heard multiply the bottom one times 2 first, so I'm gonna do that one. Is everybody agreeable with that?
Yeah.
So if I multiply this by 2, this would be 4.
Minus 8 equals 26.
So that cancels, and I get 10x equals 41, then x equals 41/10. Then what would you do to find y?
So plug that in.
Substitute it into
Bottom one.
the bottom one, is that the one we want?
Yeah.
So it'd be 2 times 41/10 minus 4 times y, which we don't know, equals 13. Then so it'd be 41/5 minus 4y equals 13, then what would you do to solve?
Check 41/5.
So get an 15 is the same thing as 65 fifths, right?
Mhm.
So 65 minus 41 is 24.
Yeah.
Divide by 4, negative 4. When you divide with fraction, you invert and multiply. Did I get the same answer?
Yeah.
Yeah, I'll tell you right now, you were more likely to make a mistake using addition, elimination, or substitution if you knew the answers were fractional. You see what I'm saying? See a lot of where you can make math mistakes. Which Kramer's rule, did you ever really work with fractions? No, the fractions evolve because you get the numerator, you get the denominator. And all you gotta do is make sure you reduce it. Okay, so you can do these by other methods, but right now, this assignment, you're gonna be doing it only by Kramer's rule, so you get used to using that process. Let's do another one, that's not pretty to begin with.
That 3/4 y.
Yeah, that's 3/4. Now, I incorporated both fractions and decimals. But before I would choose to use either the fractions or the decimals, could I get rid of them? We know how to get rid of fractions, don't you? Don't you multiply by the common denominator anytime you have equations? Our common denominator would be 4. So that's gonna be 2x plus
30.
equals 20.
Mhm.
What about decimals? What do we do to get rid of decimals?
Multiply by
By 10. This is 2 tenths, so it's the same principle, but I always just say if there's one decimal, you multiply by 10. If there's 2, you multiply by 100. Okay, so we're multiplying by 10, so that'd be 2x minus 3y equals 4, not 40. Okay, and now, can we use Kramer's rule?
Yeah.
So the denominator for x and y, let's see. Josie, what are the coefficients for x's
2 and 2,
and the y's?
3 and
Okay, so evaluating that, Annalyn, what would you have?
you'd have -6 minus 6.
Numerator for x. So, Tatum, what would I do to find the numerator for x?
You would replace it so it would be 20 and 4 in the x column, and then you would have 3 and negative 3, sorry.
So evaluating that, Mary Lynn, what would you have?
-16 minus 12.
Minus what?
12. Be -17.
Numerator for y. Riley, how will we set that one up?
Add 2 and 2 for the x column, and then 20 and 4 in the y column.
So evaluating that, Carissa, what would you have?
And 8 minus 40.
So what is that, negative 32? So our answer, what's the denominator for both? Okay, what's the numerator for x?
Negative 32.
And then negative 32 for y? So what's 72 over 12? 2 negatives make a positive, so it's going to be 6. And 32 over 12, I can take 4 into both of them? So that'd be 8/3. So 6 and 8/3, and then can we check it?
Yeah.
So those you got the fraction calculator. What's 1 fraction 2 times 6 plus 3 fraction 4 times 8 fraction 3 equals, and it should show up 5. Nope.
Yeah.
Yes?
Yeah.
Oh, okay, I thought you said nope. I said we got trouble.
Yes, that's right.
Okay. Now I want you to see, if you notice what you need to do on this next problem. Oh, hold on, I mean to have a plus here, sorry. Got carried away with the equal signs. gotta get your x's and y's on the same side, and then the constant has to be on the, okay, so what would we do to move the x or the y?
You
Subtract 3y? So 2x minus 3y equals 4. Now, the second equation, what do we need to do? Subtract 12x? But the key thing is you gotta line up the x's and the y's, so be careful with that. So this would be equal to what? 0. Okay, so Robert, we're back to you. What would the denominator for both our x and y be, the setup of it?
It would be 2, 12,
Negative 12.
3, 5.
Okay, Nick, let's see, Nick, can you get to evaluate it?
10 minus 36, and negative 26.
Was that 5 not y not negative?
Our 5 was just a regular 5.
That's not like that.
Numerator for x. Aaron, what do we have to do to set it up?
Change it to the constants.
Okay, so the x column now becomes a constant, so that's what, 4 and 0 go in that place?
Yes.
So if you want the numerator for x, it's the x that has to change, okay? So, Dylan, what would you get when you evaluate it?
20 minus 0, which is 20.
Numerator for y, Nicholas, how would we set it up?
Would be 2 negative 12 for the x column. And we have 4 and 0 for the y.
Good. And now Spencer, you get to evaluate.
It'd be 0 minus the negative 48.
So 48 positive then? Now, what's the denominator for each?
Negative 26.
Numerator for x
20
and 48 for y. What's that reduced to? We're going to reduce by 2,
10,
10 over 13.
and then 24, 13.
negative 24 thirteenths. Everybody agreeable with those answers?
What's the,
We just reduced them? And then if you've got a calculator and you want to check it, or if you mentally want to check it, that first one, 2 times the negative 10 thirteenths, well, 10 fraction key 13, minus 3 times negative 24 fraction key 13, hit equal, and hopefully it's 4. Anybody check it? We agree?
Yeah.
Good? Okay, you guys have questions on what we're doing?
No.
Okay, let's look back, let's see. 4 and 6, no, yeah, 4 and 6 at the top. Notice number 6. What did I have you do on 6? What do you notice about number 6?
Fraction.
It has fractions. Can you get rid of the fractions?
Yeah.
Yes. Could you work with the fractions?
Yeah.
Yes. So you have the option, if you want to get rid of the fractions, multiply by the common denominator. If you want to work with them as they are, you can keep them and just use your evaluation of your determinant as you go through the process. Do you guys have questions on what you're doing on that page 192, right?
Mhm.